Hello, after lectures on Wronskian determinant, today we are going to move towards solving the second order homogeneous linear differential equations. So today we are going to study how to solve second order homogeneous linear differential equations. Okay, so or I would write any nth order linear differential equation if you want to solve how to solve. So in particular, first we are doing second order homogeneous differential equations and how to solve these differential equations. So the solution of so one of the ways can be the method of symbolic operators. One of the ways to solve them is first of the method that I'm going to mention is method of symbolic operators. So we want to study what is known as method of symbolic operators. Now, if your differential equations is, let's say, a naught d square plus a1 d plus a2 times y is equal to 0, where a naught, a1, and a2 are continuous functions of x. So they are continuous functions of x. So they are continuous functions of x. And if I want to solve these differential equations, the solutions to these homogeneous uh, linear differential equations, I can extend this entire idea to nth order also. But right now I'm sticking to the second order linear differential equations only. So the solutions for the differential equations of this type are known as your complementary functions. And I'm not going to derive them, but we're going to just see how to write solutions for different cases. So complementary uh, function. The solution for the second order, or in general nth order homogeneous linear differential equations, are called as complementary functions. These are called as complementary functions. Is that clear? Now, uh, the methodology in method of symbolic operators is to first find an auxiliary equation corresponding to this linear differential operator. So corresponding to the linear differential operator, this we try to find the roots for the corresponding polynomial. So like this is the linear differential operator. We create a polynomial out of it. So basically what we do, we create an auxiliary equation. We create an auxiliary equation, an equation which can be factorized in terms of the roots. Here it is. And what we try to find on the basis of the nature of these M1 and M2, we write the solutions. Okay. So in the method of symbolic operators, I'm reiterating, what do? We actually solve this linear differential operator in a form of a auxiliary equation. We try to factorize it in terms of the roots. And once we know the nature of the roots, accordingly, we'll write the solutions. Okay. So the first case can be if M1 and M2 are both real, this complementary function, which I'm going to write it as yc, is given by c1 e to power m1x plus c2 e to power m2x. This is how your solution can be presented. So complementary function is equals to c1 e to power m1x plus c2 e to power m2x when m1 and m2 are real and distinct roots. So both real as well as distinct I'll write here. Okay. Now if at all you see, if these m1 and m2 are real but also equal roots, then in order to create like one of the solution would be c e to power m1x, but in order to create another linearly independent solution, a methodology is taken by which we get this. So I'm not going into the depth of the derivation part. I'm just doing it. Probably we may do it in later cases when we're going to see these things in more detail. Right now, as I told you earlier also, my methodology teach right now is to focus on questions at first. So at least you should get an idea how to solve the questions and how to, once you should know how to solve the question. Okay, so that is my first priority as of now. And if at all it happens that these two roots are imaginary, that is, it is alpha plus iota beta and M2 is alpha minus iota beta, and this is from the theory of equation. It says that if one of the roots is a complex number, then the other root will be its complex conjugate. Okay, and if this is the case, then the solution, which is the complementary function, is given by e to the power alpha x, and you can write a sine beta x, and you can write here b cos beta x. Okay, so these are a few methods by which you can, what you can do, you can find the solutions to the homogeneous linear differential equation. And now right now I'm discussing a second order homogeneous linear differential equation. Again, I'm reiterating the solution for this is obtained by solving this particular linear differential operator in the form of an auxiliary equation. If you try to factorize this term into roots, then on the basis of the nature of the roots, you get the various solutions, and some of them I have written here, like 3 of them I have written here. I hope it is clear. I think anybody should not have any doubt here right now. अभी इसमें तो कोई दिक्कत नहीं होनी चाहिए. Is that clear? Okay. Like for example, the similar things I can extend to the n dimensions also. So if I discuss for the same for the nth order linear differential equation, or you can say nth order homogeneous linear differential equation. So if I want to do that also, I can do the same. I can expand the entire concept to the same. Okay. So in order to find the solution for the nth order homogeneous linear differential equations, the same strategy is employed. What you do, you try to expand this linear differential operator. Okay, you try to expand this linear differential operator, probably given by a naught d raised to power n, a1 d raised to power n minus 1, dash dash dash. You can write a n minus 1, you can write d here, and then you can write plus a n. So if you write like this entire term and try to factorize it in terms of its roots. So let's say if you try to factorize them in terms of its roots, on the basis of the nature of the roots, you can write the solutions. So for example, for instance, if your all these mi's are real as well as unequal, real as well as unequal, the solutions can be written as simply in this form. Okay, this is how you can write the complementary function. So complementary function would then be equal to the linear combinations of e to the power mi's x, where mi's are the roots for the this particular auxiliary equation. This is sometimes referred to as your auxiliary polynomial or auxiliary equation. I hope it is clear till now. And further as I move, let's say there are, you can say, let's say there are 3 equal roots, for instance, or n minus an equal root. So like just giving you an example, there are, let's say, 3 equal roots. M1 is equal to M2 and is equal to M3, and all other roots are unequal. So all other roots like M4, M5, so on are unequal. So these are unequal roots, and let's say there are 3 equal roots. So how to write the solutions for the same? The complementary function, or you can say the solution for the second order homogeneous linear differential equation, in this case would be equals to C1 plus C2x plus C3x square. You can write e to the power m1x, or you can write all these equations, like all these roots as m. And then you can write C4 e to the power m4x, and then you can write C5 e to the power m5x, and so on and so forth. I hope it is clear. And if the roots are imaginary, let's say m1, m2, m3, dash, 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 mn, all of them are imaginary. And then what you have to do, simply write this solution. This will work here also. So what you'll be confused. You'll say that, okay, why did you write in this fashion here? How did I write in this fashion here? I wrote in this fashion because I already explained you that if m1 is equals to, if I've taken m1 is equal to alpha plus iota beta, and m2 if I take alpha minus iota beta, for instance, there are only two roots, then what happens is I will simply write solution as c1 e की power m1x and c2 e की power m2x. So even this would do. But when I try to solve this entire expression, what I'll get alpha plus iota beta, and then I will write x here, and then I will write c2 e की power alpha minus iota beta x here, and I can take e की power alpha x common. So if I take e की power alpha x common, so I'll get here c1, and I will get e की power iota beta x here plus c2 e की power minus iota beta x here. So this is how I'm going to get things up. And if I want to expand this from the complex numbers, you know that this is e की power iota theta is written as some linear combination of cos and sines. So in general, you can write it as a cos beta x plus b sin beta x. Is that clear? So in short, in general, the solution in any way would remain c1 e की power m1x plus c2 e की power m2x only. What has happened is that since I have written that one of the roots is alpha comma beta, another roots is alpha minus beta, then I can reduce it to this expression. Okay, I can reduce it to this expression, but primarily this is the solution. And similarly, if there are n roots, you can write in this fashion, and then you can use all these strategies to lower it down to some easier expression. That is up to you. Is that clear till now? I don't think there is an issue till now. So let us do a question first, and then move forward to uh, particular integrals and discussions over that. Okay, till now everything is clear. I don't think there is an issue till now.
Yes, sir, clear.
Okay, so let us start with a difficult question at first. This was asked in GATE mathematics. And another thing that I want to tell is that, for example, now I'm going to teach you a few more things. Like I've already stated that I've taught you a Green's function. Most of the part we've studied, and most of the part in Green Dirac delta function also we've studied. So people who are just joining or have just joined, kindly revise that topic. So we are going to do previous year questions there as well. And secondly, like for example, whenever I teach, it's not about it's not always about exam. Okay, the purpose of me teaching you is not only exam but beyond it also. Even if you clear the exam, then you're going to suffer an interview. Okay, so that is why I teach you things in little more detail than what a competitive teacher would do in general. So don't see those lectures as well. For example, Laplacian equation we've solved in around like 9 to 10 lectures, and probably 2 to 3 lectures are still there. But I see that there is no participation there. I'm not disappointed, but I do feel that those lectures are very important because, see, even if you clear the exam, you have to face an interview to get into a PhD, right? So there you are going to suffer a lot, because then you would know how to solve a question, but you do not know what goes beyond question. So that is where those lectures are also important. So kindly keep the participation there as well. So that will help you out anyway. Okay. So that is my request. Otherwise, it's all up to you. Okay. So assume that all zeros of the polynomial. So all zeros of the polynomial. And you have to keep this in mind that I'm writing all zeros of the polynomial given by an x raised to power n, an minus 1, x raised to power n minus 1 dash dash dash, a1 x plus a naught have negative real parts. Have negative real parts. So you're having this polynomial, which is given by an x की power n, an minus 1 x की power n minus 1 plus a1 x plus a naught have all negative real parts if u as a function of t is any solution to the ordinary differential equation given by an dnu upon dtn plus an minus 1 dn minus 1 u upon dtn minus 1 dash 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 a1 du upon dt, and then you have this a naught u equal to 0, then limit t tends to infinity, limit t tends to infinity ut is equal to which of the following option? So the question says which of the following option is then correct. Okay, so 0 is 1, then option number B I can write 1, and then C option I can write n minus 1, and D option I can write infinity. So anybody has got any insight to this question? Is Bharat there today? Yes. Okay, Pooja has joined today. Okay.
Yes, sir.
So okay, chalo. So assume that all zeros of the polynomial a n x की power n plus a n minus 1 x की power n minus 1 a1 x plus a naught have negative real parts. Okay, so what does it mean, or what does it infer? That in general, let us write. See, in general, always understand real numbers are nothing but they are subset of complex numbers only. Okay, so real numbers, real numbers are nothing but they are the subset of complex numbers. So real numbers are subset of complex numbers. Okay, so your complex number are in general denoted by x comma y, and if you write your x is equal to 0, basically you are actually writing a real number only. So it says that you have a negative real part. What does it imply? It implies that in general, if I assume the roots to be complex, okay, if I assume the roots to be complex, which in particular case can be real as well by keeping the imaginary part as 0, it says that the real part has to be negative. The first thing is clear, and regards what? Regards this particular polynomial. The polynomial is given to you a n x की power n minus 1, a n minus 1 x की power n minus 1 plus a1 x plus a naught. And it further says that if ut is any solution to ODE, that is, this is the ordinary differential equation given to you. And if what was the methodology I taught you? The methodology is to write this particular thing in form of this. So this is how I'm going to write. And this is nothing but it is again a function of d. What is that function of d? This is a n d raised to power n plus a n minus 1 d raised to power n minus 1. Then I have a n minus 2 d raised to power n minus 2, and so on and so forth. I'll write here a1 and I will write d here plus a naught. So this is your linear differential operator, and this is some function of d. What I have to do, I have to find the roots for this. Once if I find the roots of this, only then I'm in position to write anything. Okay, write any solution, right? So it says that whatever is the solution for this differential equation, whatever is the solution has a negative real part. What does it mean having negative real part? Means if I consider that there are okay, so let me take the worst case, that is if all the roots are complex, and let's say I'm not going to complicate it much, but let's say if n is an even number. Okay, so just give me another just if somebody is understanding, can n be odd? Can n be odd if all the roots are complex? So I'm considering the case where all the roots are complex only. So the most general case would be this, that all the roots take them as complex and take all the real parts as negative. Okay, you can argue that why I'm doing so, because the real numbers after all are subsets for complex numbers. So in general, if I make a statement for complex number, all I need to do for real numbers is to keep the imaginary part as 0. So I'm taking the most general case. Now my question is, can n be odd if all the roots are complex? अगर इस पूरी differential, इस पूरी polynomial की, like this is your polynomial FD have written, इसकी अगर n में इसकी डिग्री बोल रहा हूँ, and I'm now saying that क्या सारे roots अगर complex होते हैं तो क्या n odd हो सकता है? Can n be odd if all the roots are complex?
No, sir.
No. Why?
Because sir, conjugate वो pair में अगर करती
In
complex
any
roots.
case, if one root exists, then another root has to be the conjugate one. Okay. So in any case, if I say that all the n roots are there, if all the n roots are there, then obviously these all the n roots are there and they are all complex. Then these total number of these roots must be even. It cannot be odd, because if one survives, then what about the conjugate of that, the lone survival? Is that clear? So what I will do, if n is even, then if alpha 1 plus beta 1 exists, alpha 1 comma beta 1 exists, then alpha 1 minus beta 1 would surely exist. If alpha 2 comma beta 2 exists, then alpha 2 minus beta 2 surely exists. And in this manner, I can write alpha n minus 2 comma beta n minus n, sorry, n minus 2 बोल रहा हूँ, alpha n by 2 comma beta n by 2 exists, then alpha n by 2 minus beta n by 2 would surely exist. This will form in totality n roots. Is that clear? So you have n by 2 here and n by 2 here, so total n roots. Is that clear? And I've assumed all of them to be complex. This is the, you can say, worst case possible. That is, if all the roots are complex. You can obviously say that some of the roots are complex and then some of are then real. Then what about what sum is there? Like kitne hain? To ye nahi pata. So in general, because whatever it was given in the question is like it has given just that they have negative real parts. So I'm assuming that all of the roots are complex. If all the roots are complex, then obviously what I can say, that let us say that these are the roots, say alpha 1 comma beta 1 is the root, so another root would certainly follow. The conjugate one would certainly follow. Is that clear? So overall, I can write, and if these are the roots, I know the solution will be of the form C1. I told you the most general form of writing this is this. I hope it is clear or not clear.
Zero आंसर.
हाँ जी.
तो जीरो हो जाएगा फिर इसका.
हाँ बिल्कुल zero हो जाएगा, right, exactly. And all these alpha i's are given to be negative. All these alpha i's are given to be negative. If all these alpha i's are given to be negative, what will form? What will be there? So I'll write C1 e की power alpha 1 x plus iota beta 1 x, and then I will write C2 e की power alpha 2 plus iota beta 2 x, and so on and so forth. And at the end, I'll write Cn by 2 e की power alpha by 2, and I'll write plus minus also. Okay, so I'll write alpha n by 2 plus minus iota beta n. Is that clear? So all of these possible roots I'm going to write. Like C, you can argue that why did you write only C1? I'm right now not concerned about C1s and C2s and all those stuff. Or you, if you want to write, you can even write C1 plus C1 bar or something like that. But overall, this will be the in general solution. Is that clear? Or is that not clear? बच्चों को समझ में आ रहा है नहीं आ रहा जो बालक ने ज्वाइन की. देखो बेटा, क्या कर रहे हो आप? सिंपल, जब आपके पास कॉम्प्लेक्स सारे के सारे रूट्स है ना, तो क्या करने का है, सीधे यू जस्ट प्लेस देम ओवर द एक्सपोनेंशियल टर्म, राइट? दिस इज हाउ यू डू. मैंने बताया था कि अगर टू डायमेंशन लाइक सेकंड ऑर्डर की डिफरेंशियल इक्वेशन होती है, तो ऑब्वियसली इट बॉइल्स डाउन टू दिस थिंग. Okay, so it turns out that your solution can be written in more like you can say compact form, or you can say that it can reduce to this particular form. If your two roots are alpha plus iota beta and alpha minus iota beta. In general, you have to write in this fashion. Okay, in general, you have to write in this fashion. So, किसी को समझ नहीं आ रहा तो पूछो यार. रजत समझ में आ रहा है? सलोनी, प्रज्ञा, भारत, पूजा चली गई. ठीक है. अब देखो यहाँ से देखो, सारे अल्फा इज नेगेटिव है. And understand that e की power iota beta I, in any case, this would be some cos beta I x. Forget about constant. Just don't worry about it. Right now, just think about this. So let's चलो मैं constant भी मान लेता हूँ तुम्हारे लिए. So let's say इसका कुछ constant लगा, and it is equals to uh, c cos beta I and again c sin beta I. Okay. Always remember, if I write a sin theta plus b cosine theta, this always lies between minus root over a square plus b square. This is something that I'm going to derive someday, but overall understand this remains to be a bounded function. So this is a bounded function. In general, this is a bounded function. And in fact, even if you add them up, like if you try to add them up, this will anyway remain bounded function. This will anyway remain bounded function. Cos beta I, you know that it remains between -1 and 1. Sin beta I, you know that it remains between -1 and 1. Overall, you know that this particular expression is a bounded function. Okay. So now understand what was given in the question. It was given in, it was given in the question about like independent variable is t there. So I'll write t here, sorry. So I'll write t here. Okay, now it says that as t tends to infinity, and this was not yt, this was, I think, u it was given. Sorry. Okay, so it was given u here, sorry. Okay, so हम देख रहे थे कि this was like u here. Okay, so I'm writing that u as a function of t can be written as c1 e की power m1 t, c2 e की power m2 t, cn e की power m1 t. And if and it was asked that what is limit t tends to infinity ut. So it will be equals to limit t tends to infinity c1 e की power alpha I, है ना, ऐसा मैं लिख देता हूँ जैसे कि तुम्हें समझ में, समेशन प्लस beta I x, your alpha where I varies from 1 to n by 2, plus summation I equal to 1 से लेकर n by 2, some another you take constant, let's say c2 or ci बोल दो इसको भी कुछ ci और यहाँ कुछ और बोल दो इसको, let's say ki बोल दो, और यहाँ पे आ जाता है e की पावर अल्फा I t, बार बार गलती हो रही है, अल्फा I t plus beta I t. Is that clear? Now you see in each of these terms, you see that there is some, if you write it in this fashion, इसको ऐसा भी लिखा जा सकता है, you can write it as ci e की power alpha I t into e की power beta I t iota, and then you can write in this fashion ki's, and then you can write e की power alpha I t into e की power beta I t minus, sorry, this is minus. Okay, now you see that as t tends to infinity, e की power alpha I t would tend to 0 because alpha i's are given to be negative. Since alpha i's are negative, so e की power alpha I t would be tending to 0 only. E की power beta I t, iota beta I t is a bounded function, so it is not going to vary much. It is still going to be some bounded number only. It is going to be some bounded number multiplied with 0, 0, multiplied with 0, 0. Overall answer क्या आएगा? 0. Is that clear or is that not clear? Is that clear or not clear? कहाँ चले गए सारे?
Clear, sir.
Okay, चलो जी, अब आगे बढ़ते हैं. Okay, so I think I hope this is clear to you. A few questions from exam, देखते हैं इसको भी थोड़ा सा पता लगना चाहिए तुम्हें कि एग्जाम में क्या है. Then we'll move on. Okay, so let us do a question which was asked in TFR examination. So your TFR question, physics only. Okay, so this is from physics only. So what does it? हाँ बोलो.
सर e to the power iota beta t वाला फंक्शन हमेशा बाउंडेड रहेगा क्या?
बिल्कुल बाउंडेड रहेगा. देखो e की पावर आयोटा बीटा आई टी ऐसा लिखूं मैं, इसको क्या लिखोगे तुम? cos बीटा आई टी प्लस sin बीटा आई टी. well obviously there would be some constant, I'm not writing them up, so it will be some constant, isn't it? Because होगा क्या कि जैसे this ci would anyway remain, है ना? So overall this particular term, even if you add like for any time, so for example if I add it, ultimately क्या होगा? c2 c3 c4 cn cos, मतलब मैं कैसे समझाऊं इस चीज को? देखो मैं जो समझाने की कोशिश कर रहा हूँ, चलो मैं ऐसे करता हूँ, थोड़ा सा क्या वो मैथमेटिकली रिग्रेस हो जाएगा, लेकिन वो भी कर सकते हैं. ये लो देखो, चलो e की पावर अल्फा आई टी और क्या था, इनटू e की पावर बीटा आई टी, राइट? ऐसा कुछ सम चल रहा था और कुछ कांस्टेंट है, आई एम नॉट राइटिंग दोस कांस्टेंट, टेक अ मॉड ऑफ इट. सो क्या आएगा? e की पावर अल्फा आई टी इंटू e की पावर, एक वन लिखो इधर, मैं सिर्फ पॉजिटिव के लिए कर रहा हूँ, सिर्फ पॉजिटिव के लिए पर करके इनको मल्टीप्लाई कर रहा हूँ. मतलब ये जो चीज लिखी है ना, e की पावर अल्फा वन प्लस आयोटा बीटा वन टी, इस चीज को मैं ऐसे मतलब हर चीज, हर इंडेक्स आई के लिए लिख रहा हूँ. अल्फा टू टी इंटू ई की पावर आयोटा बीटा टू टी, आयोटा है ऐसे करके e की पावर अल्फा एन टी एन बाई टू टी e की पावर iota beta n by 2t. Is that clear? इसका मॉड ले लो, ले लिया मॉड, मतलब इसके मॉड लेने के बराबर हो गया। अब देखो ये जो मॉड है विल बी लेस देन इक्वल टू e की पावर अल्फा आई टी का मॉड e की पावर आयोटा बीटा। चलो मैं एक बार ढंग से लिख देता हूँ तुम्हारे, ये ऐसे एक्चुअली क्या है, sometimes I just take a shorter route because probably okay, is that clear? This is from triangles inequality. Okay, so triangles inequality says that if a1 plus a2 plus a3 का mod लेना है, it is always less than equal to mod of a1 plus mod of a2 plus mod of a3 dash 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 mod of a2. This is triangles inequality. Is that clear? Now, what will
Yes.
be less than equal? Because I know that e की power iota beta 1t का mod is always equal to 1. Is that clear? Because you see, this would be like cos
Yes.
beta 1t plus iota sin beta 1t, isn't it? ये ऐसे तो होगा, ऐसे तो कुछ होगा। देखो ये मॉड लगाएंगे तो दिस इज इसका मॉड और इसका मॉड क्या होता है, 1 ही होता है। रूट ओवर कॉस स्क्वायर बीटा 1t प्लस साइन स्क्वायर बीटा 1t, दिस वुड बी 0। सो ये किससे छोटा होगा, e की पावर अल्फा 1t का मॉड प्लस e की पावर अल्फा 2t का मॉड डैश 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 e की पावर अल्फा n by 2t का मॉड। इज दैट क्लियर? सो ये जो तुम्हारा एक्सप्रेशन है ये तुम्हारा फर्स्ट ब्रैकेट है जो मैं यहाँ लिख रहा हूँ, उसका मैंने मॉडुलस वैल्यू ले लिया। क्या ले लिया मैंने, जानबूझ के मॉड लगा दिया, दोनों साइड जानबूझ के मॉड लगाया। इज दैट क्लियर? And then I've used the triangles inequality. Is that clear?
Yes, sir.
Okay. Now take on both of the sides t tends to infinity. On both of the sides take t tends to infinity. On the left hand side take t tends to infinity. T tends to infinity modulus of e की power alpha I t e की power, sorry I've forgotten about beta iota here, iota beta I t का mod, it is less than equal to what? So as t tends to infinity, this will, this entire thing would become 0. This entire thing would become 0 0 0 because alpha i's are all negative. Is that clear?
Yes, sir.
अब किसी मॉड्यूलस की वैल्यू क्या लेस देन 0 हो सकती है? सोचो, किसी मॉड्यूलस की वैल्यू क्या लेस देन 0 हो सकती है? नहीं। इसका मतलब क्या हुआ, इसकी मॉड्यूलस की वैल्यू क्या होनी चाहिए, दिस मॉड्यूलस e की पावर अल्फा आई टी e की पावर आयोटा बीटा आई टी इन द लिमिट t टेंड्स टू इंफिनिटी, ये किसका होना चाहिए, 0। और किसी मॉड्यूलस की वैल्यू अगर 0 के बराबर है, इसका मतलब अंदर वाली चीज क्या होगी, 0। इज दैट क्लियर? सो ये जो पूरा क्वांटिटी जो तुम देख रहे हो हियर, इट विल टेंड टू 0 as t tends to infinity. So because you are in physics, so I was thinking कि थोड़ा सा easier way में समझा दो, तो I told कि ये चीज जो होगी वो कुछ like bounded ही रहेगी anyway. It will remain bounded anyway. So as t tends to infinity, this will not blow up, और like ऐसा कोई scenario नहीं आएगा कि as t tends to infinity, this will go to infinity or some that case. So in any case, this will remain bounded. मतलब ये जो जितने terms दिख रहे हैं ना तुम्हें, e की पावर iota beta I t, this will anyway remain bounded. This is a bounded function. You can see that mod लोगे तो 1 के बराबर ही होगा। So हमें पता है कि this is a bounded function. So even as t tends to infinity, this would be some constant value. I don't know about the constant value. It will be between -1 and 1, but it will be a constant value multiplied with 0. So all of these terms would become 0. Adding all these terms, zeros, like n times also would give you n only. So n by 2 into 0 plus n by 2 into 0 would give you 0. I hope it is clear now. And
Yes,
this is the most perfect approach that I've written. ये थोड़ी सी mathematical approach है. Not everybody would get it. So I actually मैं थोड़ा सा उसको थोड़ा सा नहीं देखता उसमें। So I hope it is clear. बच्चों को समझ में आ रहा है कि नहीं आ रहा, बिल्कुल ही ऊपर से जा रहा है।
आ रहा है सर।
ओके, धन्यवाद। चलो अब अपन करते हैं एक क्वेश्चन TIFR से। So the question was asked in TIFR 2015. And I will do differential equations separately for mathematical physics. So you have to attend that lecture also. But obviously that will not contain all these questions, these things like this. ये मैं सिर्फ इसलिए कर रहा हूँ so that at least you get the gist of how to solve these. So consider the ordinary differential equation, and it was given d2y upon dx2 is equals to -4y plus dy by dx. With boundary conditions that at y x equals to 1 by 5, y is equal to 0. So at x equal to 1 by 5, y is 0. It says that when plotted as a function of x, so I'm writing exact language of TFR, when plotted as a function of x for all x greater than 0, we say with certainty. So this is how they write the question. So again, I'm saying, किसी को भी prepare करना for PhD, at least prepare for TFR. See, the language itself is quite like they are saying with all certainty, and all these kind of language you're not going to find in that exam. So first increases, then decreases. First increases and then decreases to 0. And then the second option is first decreases, then increases to 0. I don't think this can be an option anyway, but koi baat nahi. The third option is has an extremum in the range 0, 1 and has an extremum. Extremum matlab maximum या minimum कुछ भी हो सकता है. In the range 0, 1. And option number D says oscillates from negative to positive. Oscillates from negative to positive with decreasing amplitude. Amplitude to 0. Okay. Okay. So how to go about this question? Just try to solve this question. I'm giving you around 3 minutes because there are only 3 minutes left of the lecture. Then I'll solve this in the next session.